Okay, this is 11.2. Quick review on series. You're just adding up sequences. And the most important rule is don't get confused between when you're dealing with sequences and when you're dealing with series. And second rule is see rule number 1. Okay? It's really hard to keep track of when you're dealing with which. Okay? So for example, this sequence, 1/2, 1/4, an eighth, a 16th, that goes to 0, but it adds up to 1. So the sequence goes to 0, the series goes to 1. Sequence of partial sums is a different thing, and that's where you're adding up a piece. So the first partial sum is just 1/2. The second partial sum is 3/4. You're adding those. The third partial sum is 7/8. So you just keep adding more and more pieces, and that would be the sequence of partial sums. Okay, and the sequence of partial sums goes to 1. It's the same as saying that the series sums up to 1. I mean, they both have to go to the same place. It's a very formal way of saying what's going on, but it's necessary sometimes. So here's a question. What if we want to add up the following sequence? 3 times 2/3, 3 times 2/3 squared, and so on and so forth. So the ANs are 3 times 2/3 to the power of n, and I let n equals 0, and so forth, as opposed to just starting at 1. Okay? So we will actually do the sequence of partial sums second. First, we're just going to find the whole ball of wax. What you do is you start with this expression for the sequence, the series, and then you basically look and say, all right, I want to get rid of this 3. There's 2 different ways to get rid of the 3. You can just subtract it. So take s, subtract 3, and there you go. You got rid of the 3. But the other way you can get rid of the 3 is by multiplying through everything by 2/3, just like so. Because everything gets shifted then, right? Because since there's already 2/3 all over the place, then what's going to happen is you're going to just shift everything over and get rid of the 3. So this is a special trick, a geometric trick, is that since you're subtracting 3 or you're multiplying by 2/3 is getting you to the same result, you can set them equal to each other and solve and find out that it equals to 9. So the geometric series in general is a times r to the n. Let me show you another example, repeating decimals. So let's say in this case you have a block of 3 digits. So if you multiply by 1,000, you shift. Why 1,000? Well, you have to multiply by the right amount so that this trailing decimal is the same in both cases, which allows you to subtract it. Then you get 999, d equals 123. So it's not lowest form, but I don't care. That's not the point. The point is we can now change any repeating decimal into a fraction. And I mean the size of this block, I mean if this block is 7 digits long and it repeats, then you're going to have 7 9s on the bottom of your fraction, okay? And so if you have like 3 9s is a third, right? The way we can figure out how might we arrive at 3 9s, if you have 0.33333, okay, 10s is 3.3333, and then you do a subtraction, so you get 9s is equal to 3, s equals 3 over 9, okay? So it works. It works with everything you know and love. All the fractions you already love. Okay, well, how do we do sequence of partial sums? Well, we have the same sequence we've been talking about. Just looks like that. And I'm going to just factor out the a's just to make things neater. One way to do this is to just, if you've seen this trick before, you say, if I multiply both sides by 1 minus r, something nice will happen. And it does. Okay, so first of all, you get all these terms back because you multiply by 1, and then you multiply by negative r. So most of these terms you get to subtract back out. And all you're left with is this plus 1 and this minus r to the n plus 1. Those guys are left. And so that's fine. Most of your stuff just cancels out, and then you're left with, you do your little division. So this is for partial sum here. Now, this is not in contradiction to the formula we got up above. Well, we didn't quite get a formula up above. But if you're going for the whole ball of wax, it's just a over 1 minus r. But you can get that from this formula anyway, because r has to be less than 1. See, when you raise it to a power, it disappears. So that term just drops out. It's just gone. So that piece, this extra piece, is only important because we're trying to do some chopping. If we're not doing any chopping, then that piece just disappears. All right. So this is what it looks like. This is how you sum up geometric series. Okay? Okay, special famous example. This is your alternating harmonic series. And you just have this partial fraction decomposition, and you guys are pretty good at that, so I'm not going to go through that. But you end up with 1 over n minus 1 over n plus 1. We call this telescoping because it looks like pieces of a telescope sliding out. And these guys are going to cancel, these guys are going to cancel, the next two are going to cancel, the next two are going to cancel, and you're left with just a 1. A finite number of terms won't affect convergence. So this means you can have any kind of garbage for the first 1,000,000 terms or so, but then it has to settle down. All right. This is just something I saw in the book. I don't even remember at this point what it was, but it looked interesting to me, so I was like, ooh, I should warn them to try that. But it's very similar to these guys, so I'm pretty sure it is anyway. Okay, so my turn. I'm going to try to do this summation right here. And yeah, okay, lovely. Don't you love my special tools that make rectangles for me? There we go. Alright, so partial fraction says if we have a over n plus b over n plus 3, gives us our fraction. So I like to multiply top and bottom over here by n plus 3, top and bottom over here by n, and then we get to get rid of all these denominators, right? So we get an plus 3a plus bn equals 3. And then, of course, there is no n's. And so an plus bn equals 0n, which means a plus b equals 0. But we also have 3a equals a. So a equals 1, and that means b equals -1. This is pretty easy to split up. Now, the trick is to see what's happening. So that partial fraction is not the problem. The problem is figuring out how to line them up so that they all telescope nicely. And so after messing around with it, I was pretty sure only the 1, 1/2, and 1/3 stuck around and everything else canceled out. But I thought it was just more obvious if I stacked the terms, you know, a row of 3, another row of 3, another row of 3. But then for every couple here, other than the 3 that are circled, for all the other couples, for example, the second part of an ordered, you know, think of this as an ordered pair here. The second one always cancels out with the first one down below. The second piece cancels down with the first one down below. Excuse me. So when you line them up this way, it makes it obvious what's happening, and then you just say 1 plus 1/2 plus 1/3 sums up to 11 over 6. Okay. Which is not not over 7, it's 11/6. Okay. Now this is going back to our rule that we had above, way up. No, where was it? Aha, this guy. And of course, r has to be less than 1, otherwise this thing is going to blow up, right? Like if r is 7, what are you going to get? You're going to get 1 minus 7 in the denominator, and that's just nonsense. This is just ridiculous. That's not gonna work. Okay, so, there we are. So we had A over 1 minus R, but see, this is garbage, because, see, this whole piece, the R, is greater than 1. So this whole thing, no, this doesn't work. This thing does not converge. But if it's E over 3, that's a whole different story, because E over 3 is totally fine. You just chuck it into your formula and you're good to go. You don't have to recalculate that. So on an exam, if I said, you know, sum up this geometric sequence, sorry. See, I just broke my first rule. This is a geometric series. So if, you know, I can just chuck that into my formula and it works. And, yeah, if I say on an exam, show me, without relying on a formula, show me all the steps, then you would have to go back to, you know, this kind of discussion. Yeah, okay, that's it for 11 point.